Hello everyone, I'm Sherlock Holmes to talk about debugging in production and developer observability. But first, a few things about me. I was a consultant for over a decade. I worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code and currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. I love APMs. They are absolutely wonderful. I'm old enough to remember a time where they weren't around, and I'm just so happy we moved past that. This is absolutely amazing. The dashboard, the details, we're truly at a golden age of monitoring. Hell, when I started, we used to monitor the server by kicking it and listening to see if the hard drive was spinning properly. Today, with modern scale deployment, they're so big with Kubernetes and production capabilities that we have today. Without an APM, well, we're not as blind as a bat, but it's pretty close. A lot of the issues we run into start when we notice an anomaly in the dashboard. We see a spike in failures or something like that performs a bit too slow. The APM is amazing in showing those hiccups, but this is where it stops. It can tell us that a web service performed badly or failed. It can't tell us why it failed. It can't point us at a line of code. So let's stop for a second and talk about a different line. This one. On the one side, we have developers, and on the other side, we have the ops or DevOps. This is a line we've had for a long time. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. Yes, we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation, because the ops guys don't necessarily know how to solve problems made by the developers. They know how to solve ops problems. So when a container has a problem and the DevOps don't know how to fix it, well, it starts a problematic feedback loop of test, redeploy, rinse, repeat. That isn't ideal. Monitoring tools are like the bat signal. They come up and we, the developers, we're Batman, Batwoman, Batperson, all of us heroes in these cases. We step up to deal with the bugs and we're the last line of defense against their villainy. Well, code bad people, it's kind of the same thing, but without the six-pack abs, too much baked goods in the company kitchen here. Coder Batman needs to know where the crime or bugs are happening in the code. So these dashboards, they point us towards the crime we have to fight in our system. But here's the thing, it gets hard. We start digging into logs, trying to find the problem. The dashboard sent us into a general direction, like a performance problem or high error rates. But now we need to jump into the logs and hope that we can find something there that will somehow explain the problem we're seeing. That's like going from this jet engine back to Stone Age tools. There are many log processing platforms that do an amazing job at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome, where a log is already there waiting for us. But obviously we can't have logging all over the place. Our billing will go through the roof and our performance will, well, it will suffer. We're stuck in this loop of add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours. Then reproduce the issue in the production server with your fingers crossed and try to analyze what went on. Hopefully you found the issue, because if not, it's effectively rinse, repeat for the whole process. In the meantime, you still have a bug in production and developers are wasting their time. There just has to be a better way. It's 2022 and logs are the way we solve bugs in this day and age. Don't get me wrong, I love logs, and today's logs are totally different from what we had even 10 years ago. But you need to know about your problem in advance for a log to work. The problem is I'm not clairvoyant. When I write code, I can't tell what bugs or problems the code will have before the code is written. I'm in the same boat as you are. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something. This is a bit like the dilemma of writing comments. Does it make the code look noisy and stupid, or will I find this useful at 2 a.m. when everything isn't working and I want to rip out the few strands of hair I still have left because of this damn production problem? Debuggers are amazing. They let us set breakpoints, see call stacks, inspect variables, and more. If only we could do the same thing for production system. But debuggers weren't designed for this. They are very insecure when debugging remotely. They can block your server while sending debug commands remotely. A small mistake, such as an expensive condition, can literally destroy your server. I might be repeating an urban legend here, but 20 or so years ago, I heard a story about a guy who was debugging a railed system located on a cliff. He stopped at a breakpoint during debugging, and the multi-million-dollar hardware fell into the sea because it didn't receive the stop command. Again, I don't know if it's a true story, but it's plausible. Debuggers weren't really designed for these situations. Worse, debuggers are limited to one server. If you have a cluster with multiple machines, the problem can manifest on one machine always, or might manifest on a random machine. We can't rely on pure luck. If I have multiple servers with multiple languages, platforms crossing from one to another with the debugger, well, it's possible in theory, but I can't even imagine it in reality. I also want to revisit this slide because I do love having APMs, and looking at their dashboard does give me this type of joy we get from seeing the result of my work plotted out as a graph. I feel there should be a German word to describe that sort of enjoyment. But here's the thing, APMs aren't one thing. The more you instrument, the more you have runtime overhead. The more you have runtime overhead, the more hosts you need to handle the same amount of tasks. The more hosts you have, the more problems you have, and they become more complex. I feel Schrödinger should have to deliver this next line. By observing, we effectively change some of the outcome. An APM needs to observe everything. An APM doesn't know what it's looking for. Like I said before, it's a bat signal or a check engine light. It's got sensors all over the place, and it needs to receive information from these sensors. Some sensors have almost no overhead, but some can impact the observed application noticeably. Some people use that as an excuse to avoid APMs, which I feel is like throwing the baby out with the bathwater. We need APMs. We can't manage at scale without them. But we need to tune them, and observing everything isn't an option. Thankfully, pretty much every APM vendor knows that, and they all let us tune the ratio of observability to performance so we can get good results. Unfortunately, that means we get less data. Couple that with the reduction of logs that we need to do for the same reason, and the bad problems we have in production just got a whole lot worse. Let's take the Batman metaphor all the way. We need a team up. We need some help on the servers, especially in a clustered polyglot environment where the issue can appear on one container and move on to the next, etc. So, you remember this slide. We need some way to get through that line. Not remove it. We like that line. It's a good line. We need a way to connect with the server and debug it. Now, I'm a developer, so I try to stay away from management buzzwords, but the word for this is shift left. It essentially means we're letting the developer and QA get back some of the access we used to have into the apps, without demolishing the gains we had in security and stability. We love the ops people, and we need them. So this is about helping them keep everything running smoothly in production without stepping on their toes or blowing up their deployment. This leads us here. What if you could connect your server to a debugger agent that would make sure you don't overload the server and don't make a mistake like setting a breakpoint or something like that? That's what developer observability does. Developer observability is complementary to the APM. It works very differently. Before we go on, I'd like to explain what's developer observability. Observability is defined as the ability to understand how your systems work on the inside without shipping new code. The without shipping new code portion is key. But what's developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. Developer observability acts very much like a debugger, but it doesn't put our production at risk and works well with production scale. So how does that work in practice? Each tool in this field is different. I'll explain the Lightrun architecture since that's what I'm familiar with, and I'll try to qualify where it differs from other tools. In Lightrun, we use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, or WebStorm, etc. We can also use a command line tool. Other tools sometimes have a web interface or CLI only, or integration with the IDE. This client lets us interact with the Lightrun server. This hides the actual production environment. Developers don't get access to the production area, which is still the purview of DevOps. The management server sends everything to the agent, which is installed on your production or staging servers. This is pretty standard for all continuous observability tools. The agent is just a small runtime you add to your production staging server. It's very low overhead and implements the debugging logic. Finally, everything is piped through the server back to your IDE directly, so as a developer you can keep working in the IDE without leaving your comfort zone. Okay, that should raise the vendor alert right here. I heard that line before, right? APMs have been around forever and have been optimized. How can a new tool claim to have lower overhead than an established and proven solution? As I said before, APMs look at everything. A developer observability tool is surgical. That means that when an APM raises an interesting issue, we can look at a very specific thing like a line of code. When a developer observability solution isn't running, its overhead is almost nothing. It literally does nothing other than check whether we need it. It doesn't report anything and is practically idle. When we do need it, we need more data than the APM does, but we can get it from one specific area of the code. So there's an overhead, but because it only impacts one area of the code, it's tiny. This is the obvious question. What if I look at code that gets invoked a lot? As I said, developer observability gets even more data than an APM does. This can bring down a system and, well, we could end up here. So this is where developer observability tools differ. Some tools provide the ability to throttle expensive actions and only show you some of the information. This is a big deal in high volume requests. I think these things are best shown in a demo because I can talk your ears off, but showing a quick demo can explain this faster. I'll use Kotlin for this demo, but this applies to other languages. To start, we need to sign up for a free Lightrun account at lightrun.com/free. Notice that Lightrun has a very generous free tier you can use to experiment with the product. Pretty much everything I show here can be accomplished with a free account. I'll skip the actual setup since it's covered there and we don't have that much time. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are a prime number. It sleeps for 10 milliseconds, so it won't completely demolish the CPU, but other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the result at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting a log opens the UI to enter a new log. I can write more than just text in the curly braces. I can include any expression I want, such as the value of the variables that are included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more we can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short period of time, since logging exceeded a threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. That's a relatively simple demo to whet your appetite. Let's pull out the big demo guns. So I decided to take on Netflix and build my own movie service. Seems pretty easy enough. Turns out it isn't so much, and those people on Netflix sure know how to build an application. This is rough. I'm terrible at front-end, so I hired a developer to build it in React. He also built a NodeJS server, which was pretty intuitive for a front-end person. This is actually a pretty sensible architecture. It lets the front-end developers handle all their stuff, including the start of the backend area. NodeJS scales reasonably well and can handle the stuff it's good at, communicating with the UI front-end, etc. NodeJS is also, as I said, scales reasonably well, so we're pretty good. Storage, transactions, and reliability are a decade ahead in the world of Java. So using Spring Boot for the backend heavy lifting also makes sense. I know it and built a lot of stuff with it. This is a merge of the best each world has to offer. It also lets us hire the right people for the right job. The problems start when we need to debug this, especially in production. Finding the source of bugs is a process of digging through logs with different conventions and sometimes even different terms for the same thing. And the problem is, we have bugs. So here's the app that will take over the world. As you can see, I have a list of movies in the UI that remind us a bit of those big guys who, again, are doing a pretty spectacular job here. I can add a movie to my list, I can visit my list, I can see movies within it, I can open a specific movie and see details about it. That's pretty much it. But here's the weird thing. When I click the No Time to Die movie, there's a problem. I get red notice instead. It's a weird bug, and I have no idea why it would happen. I think we can debug it using Lightrun. This is the Node.js project that implements the initial backend of our architecture. This is the method that gets invoked when we click a movie and want to see the details. This time I'll add a snapshot. Some other developer observability tools call this a capture or a non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now, let's go back to the browser for a second, and in the browser we click the movie again to produce the issue. And we wait a few seconds for the problem to reproduce. Now we need to go back to the IDE. And now we wait a second and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables just like a regular breakpoint we all know and love. But it doesn't stop at that point. So your server won't get stuck waiting for a step over. Now obviously you can't step over the code, so you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. So what do we see here? We see the ID of the movie and it seems like the right ID. So this isn't a case of a bad ID passing from the UI. We need to dig deeper into the Spring Boot server. In the Spring Boot server code, we've got the fetch movie details method, which does the actual fetching. I place a snapshot here, and I'll spare you the pain of going to the web every time. I have a curl command that performs the request, so I'm running it in a different window here, as it's not really interesting. So now we need to wait for the snapshot to get hit. If this seems to take too long, spoiler, it never gets hit. And the reason for that is the cacheable annotation you see above the method. It seems the response from the method is cached. Unfortunately, we can't rely on guesses. We need to verify. So we need to go to the movie manager, which is our REST controller. It handles all the web requests directly. So here we can add another snapshot and again try to trigger the curl script with the hope that this time we'll get it right. The snapshot will get hit. After a bit of waiting, we finally hit the snapshot in the get method. This means our request is happening, but the failure we're seeing is because the cache got corrupted with bad data. Why would that happen, and can we continue our investigation? Yes, we can. The place where the cache might be corrupted is here, in check for file updates. This method runs periodically every 60 seconds and checks the file system for an import file. This is how we add new movies into the system. We place a file with data and it imports it into the database. It might break existing movies. Let's create a snapshot here, and while we wait for a minute for the snapshot to hit, we can use the time productively to delete the no longer used snapshots from before. They will eventually expire, but they're left here in case you need references. One of the nice things about debugging with snapshots is that normally you don't have to wait. You can just place them all over the code and they get hit at some point. Great, the snapshot got hit just in time, so that means this code is working. Now all I need to do is evict the cache with the dummy file and we're done. Or are we? Notice the methods here. The batch update evicts the cache, or so it would seem if you're new to Spring. If we'll do that and check for the bug again, we'll see the cache wasn't evicted. The reason for this is that Spring only reads the annotations when they're invoked from a different class by default. This is one of those gotchas that often fail developers new to Spring. I can't believe I fell for that. This was relatively simple in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here I have a problem with the trending request. One specific user is complaining that the trending list on his machine doesn't match the trending list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So a solution is to use a conditional snapshot, just like you can with a regular debugger. Notice that you can define a condition for a log and for a metric as well. This is one of the key features of developer observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID, so I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I use the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just waiting for the user to hit that snapshot. This is the point where normally you can go make yourself a cup of coffee, or even just go home and check this out the next day. That's the beauty of this sort of instrumentation. In this case, I won't make you wait long. The snapshot gets hit by the right user, despite other users coming in. This specific request is from the right user ID. We can now review the stack information and fix a user-specific bug. The next thing I want to talk about is metrics. APMs give us a large-scale performance information, but they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. So we can do something like count the number of times a specific user reached that line of code. We also have a method duration, which lets us know how long a method took to execute. We can even measure the time it takes to perform a code block using TikToks. This lets us narrow down the performance impact of a larger method to specific problematic segments. In this case, I'll just use the method duration. Measurements typically have a name under which you can pipe them or log them, so I'll just give this method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to Statsd and Prometheus. I'm a pretty awful DevOps, so I really don't want to demo that in this case, but it does work if you know how to use these tools. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of this method. If I had more time, I'd talk about scaling this further with tools like Airflow in Python or Spark in Scala, etc. These are amazing cases where developer observability really shines, but we need to wrap things up. In closing, I'd like to go over what we discussed here and a few things we didn't have time for. Lightrun supports JVM languages like Java, Kotlin, Scala, etc. It supports a Node for both JavaScript and TypeScript code, and Python, even complex stuff like Airflow. We're working hard on adding new platforms and are doing that really fast, so if you want a new platform I didn't mention here, just write to me and I'll connect you with the product team. You can become a beta tester for the new platform and have impact on the direction taken there. When we add actions, conditions run within a sandbox, so they don't take up too much CPU or crash the system. This all happens without networking, so something like a networking hiccup won't crash the server. Security is especially crucial with solutions like this. One of the core concepts is that the server queries information, not the other way around. So that you would see with solutions like JDWP and typical debuggers. Privacy is also a crucial feature. We have PII reduction, which lets you remove private information from potentially injected logs, which helps you be compliant with all sorts of regulation around the world related to privacy. We also have block lists, which let you block specific files from being debugged. So if you have a file where user details and credentials are listed, you can block that file from breakpoints, from snapshots, and a developer won't be able to use that to spy on users. This is a really crucial feature that I didn't discuss about normal debuggers, but they're a huge security risk for internal cases. Notice you can debug them normally when you're building the system and in staging, so that's also very helpful when debugging login issues and problems of that sort. We also have a very low footprint relatively for observability because, as I mentioned before, the APMs need to observe everything, and we can observe things that are very narrow in developer observability tools. And finally, Lightrun is environmentally agnostic. That means it can work on-prem, cloud, etc. Some solutions are limited to SaaS solutions, others are limited to on-prem solutions, and you can pick and choose which solution you need. Thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions, and also feel free to write to me. Also, please check out talktotheduck.dev, where I talk about debugging in depth, and check out lightrun.com, which I think you guys will like a lot. If you have any questions, my email is listed here, and I'll be happy to help. Thank you.